Look at the jacket.
Jensen, should we turn around? Turn
around, please. Okay.
Thank you, Professor.
I am alumni of HKUST.
Yes. Yes. Jensen, it's just so nice to have you here at HKUST and in Hong Kong. Let me just say, can we just please show how much we love Jensen? Yeah!
Thank you. Thank you. I love you too.
Jensen, I have been preparing for this moment. I thought it's definitely the highlight of my HKUST career for sure. I just couldn't sleep last night for one very important reason. Because I am going to introduce you as the #1 CEO in this universe. Maybe entire universe, at least in this universe. But I was so worried. This company, Apple's stock was going up last night. And yours wasn't doing that particularly well. And I couldn't wait until the market was closed. And this morning I woke up, I asked my wife, I said, did NVIDIA hang on there? No kidding, because of we asked. So you are #1, Jensen. So we have less than an hour this afternoon. I'm just diving, Jensen, with some tough questions for you. So you have been leading this technology field, AI field, for a long period of time. Just for the sake of our audience, just tell us how you think about the AI, more specifically recently, artificial general intelligence, the impact AI is having and will have for all the society and the industry.
First of all, thank you. Thank you for the opportunity to spend time with you. Harry is one of the most consequential computer scientists of our time. And he's been a hero of mine and many others around the world for a very long time. And so it's a great pleasure to be here. Harry, as you know, the transformative, the groundbreaking capability happened when an artificial intelligence network can learn to understand data of all kinds. Of course, language and images and sequences of proteins and sequences of amino acids and sequences of chemicals. And all of a sudden, we now have computers that can understand the meaning of words and such. And because of generative AI, we can translate from one modality of information to another modality of information. For example, from text to images, from text to text, from protein to text, from text to protein, from text to chemicals. This universal, initially a universal function approximator, evolved into a universal language translator of every kind. And so the question then is, what can we do with that? And you see the number of startups around the world and the number of capabilities with the combination of all these different modalities and capabilities. And so I think the really amazing breakthrough is that we can now understand the meaning of information, incredibly difficult information. And so what does that mean to you if you are a digital biologist? So that you can understand the meaning of the data you're looking at, so that you could find a needle in a haystack. What does that mean if you are in the case of NVIDIA, a chip designer? System designer. What does that mean to you if you're in ag tech or climate science or climate tech or energy looking for a new material? So this is really the groundbreaking thing, is that we now have the concept of
really description about the amazing impacts of AI on the society. I thought that what you said really resonated with me, and to some extent even shocked me. So you kind of took us back to the entire history of human being. You said, well, there's this agricultural revolution, so we actually manufacture more food. Then we have industrial revolution, we actually manufacture more iron steels. Then we have information technology, we actually have more information. Now in this intelligence, this era, so what you are doing at NVIDIA, what AI is doing is actually manufacturing intelligence. Can you elaborate a little bit more on why this thing is just so enormously important?
Yeah, when you look at what we've done together, Harry, and you were in the middle of all of this, from the perspective of computer science, we've reinvented the whole stack, meaning the way we used to develop software, and when you think about computer science, you have to think about software development, how software is done. And so we used to code software with our hands. We imagine what the function it is that we would like to implement, whatever algorithm we like to implement, and we use our own creativity. We type it into the computer. Could be, I started with Fortran, and I learned Pascal, and then C and C++, and of course, each one of these languages allow us to express our thoughts into code. And that code runs great on CPUs. All of a sudden, now we use observed data, and we give this observed data to a computer, and we say, what is the function that you see inside this code? What are the patterns and relationships that you observe by studying all of the data that we presented to you? And instead of using coding, we now use machine learning. And the machine generates not software, it generates neural networks that are processed on GPUs. And so from coding to machine learning, from CPUs to GPUs, and because GPUs are so much more powerful, the type of software we can now develop is extraordinary. And what sits on top of it is artificial intelligence. That's what emerged. And so computer science has really been transformed pretty much at the description that I just said. Now the question is, what happens to our industry? Of course, we're all racing to use machine learning to go discover new AIs. And what is AI? And maybe that's, of course, one of the things about AI that you know very well is the automation of cognition, automation of problem solving. And problem solving could be distilled down to, if I could, three basic ideas: that you observe and perceive the environment, understand it, reason about it, and then come up with a plan to interact with it, whatever you decide your goals are. And so perception, reasoning, and planning. The three fundamental steps of problem solving. Well, perception, reasoning, and planning could be broken down into, for example, perceiving the environment around your car, reasoning about the location that you are and the location of all the other cars around you, planning how to drive. So I just described self-driving cars. That self-driving car in one manifestation would be called a digital chauffeur. And then you could do the same thing with, you observe a CT scan, you understand it, you reason about everything that you see, and you come to the conclusion there might be some anomaly that might be a tumor or something, and then you might decide to highlight it and describe it to the radiologist. Now you're a digital radiologist. In almost everything that we do, you can come up with some expression that artificial intelligence could then perform a particular task. Well, what happens is if we have enough of those digital agents, and those digital agents are interacting with the computer that's generating these digital intelligence, the total consumption of all of us into a data center makes the data center look like it's producing this thing called tokens, or what we call tokens, but otherwise digital intelligence. And so now let me now describe it a little bit differently. 300 years ago, as you know, General Electric and Westinghouse came up with a new type of instrument. In the beginning, a new type of machine. It was called a dynamo, and eventually became an AC generator. And they were so smart to go and invent a consumption of the electricity that they were able to produce. And that consumption, of course, would be things like light bulbs and toasters, and right? They created all kinds of digital appliances or electrical appliances that consumes the electricity that these plants would produce. Well, look at what we're doing now. We're creating copilots and ChatGPTs.
Intelligence.
We're creating all these different intelligence, basically light bulbs and toasters, and think of them
Amazing.
as, right?
Yes.
They're appliances that all of us would use, but you would connect it to a factory. It used to be an AC power generation factory, but this new factory is digital intelligence factory. And so what is just, from an industrial perspective, really what's happening here is we're now creating a new industry, and this new industry takes energy in and produces digital intelligence out. And that digital intelligence would be used by all kinds of different applications, and the consumption of it, we believe, is going to be quite large. And this entire industry never existed before, just like the AC generation industry never existed before that.
But that's really, truly amazing.